So we now need to solve this equation. So we're going to, as we said, we're going to subtract 2 from both sides. So we've got negative 2 is equal to negative a half times x minus 1 all squared. Now we're solving for x, so what are we going to do to both sides? Now we've got negative a half, that's the same as negative divided by negative 2 if you like. So what can we do to both sides now to get rid of that half if you like? Times it by 2 if you like. Well, let's times it by negative 2. So what I've got, well, okay, let's have a look at this. These negatives, can't they cancel out? Okay, and now let's multiply both sides by 2 because it's divided by 2 at the moment on the right-hand side. So we've got this.
Would it be the same if you divided by a half, or would that be different?
No, you'd have to times by a half, both sides.
Why is it times?
Oh, no, yeah. Getting back to it. So this is what we're left with. Now what do? We take the square root of both sides. What's the square root of 4? In terms of this question, what's the square root of 4? Plus minus 2. Thank you. Plus minus 2 is equal to x minus 1. Now the last step is we're solving for x. So therefore x is equal to 1 plus or minus 2. I don't want you leaving your answer like that because the answer is negative 1 and positive 3. Now, what I'm going to do though is I suggest when sketching quadratics is always use grey lead. I reckon we're going to nick this off because I wasn't quite happy with that sketch. It didn't look too good to me. So 1, 2. So we've got this 1, 2. I'm going to say that that's 1 there and then that's 2 there. So that's fine. And we had a y-intercept, a y-intercept of 1.5, an x-intercept of negative 1. So that's going to be negative 1 there. And I'm going to say 1, 2, 3 there. Now I'm going to trace those points together. And this here has a coordinate of 0, 1.5 or 3 over 2. Don't know how you could do that in that much room. How are we feeling with that one? All right. Pressing it now. This one, we want to halve, square and add. So half of 4 is 2. I'm squaring and then I'm subtracting 2 squared. We're not quite done yet though because now 2 squared is 4. Minus 4 minus 5 is minus 9 you should have got. It says here, hence find the coordinates of the turning point. So the turning point is at what? Turning point is minus 2 minus 9, absolutely. Now it says here, showing all important features. Now the first thing is we've got a happy quadratic, and that happy quadratic has a turning point at minus 2 minus 9, which I'm just going to say is down here somewhere. Now if we've got a happy quadratic which has a turning point there, then we know that there's going to be a y-intercept at minus 5. And we're also going to have an x-intercept somewhere. Now, that value there is minus 5. This here is minus 2 minus 9. We know that that turning point is halfway between the intercepts, but we don't know what the x-intercept is. But given the fact that we have just gone ahead and completed the square, we're then letting that equation equal 0, aren't we?
Do we have to do it like that?
You don't have to, no.
Even though you completed the square?
If you you've already completed the square, so it's not much work to find those intercepts.
Especially because that's an easy one.
Yeah, that's fine, absolutely. Now, factorizing. We could factorize this using dots, couldn't we? Couldn't we factorize this going x plus 2 squared minus 3 squared? That's dots. That's like saying a squared minus b squared. Now, a lot of students don't do it this way, which is perfectly fine. X plus 2 minus 3. X plus 2 plus 3 is what that factorises to, which is x minus 1, x plus 5, which means that if that's equaling 0, therefore x is equal to 1 and negative 5. So therefore, that has a coordinate of 1, 0, and that has a coordinate of negative 5, 0. The other way you could have done it is you could have added 9 to both sides, taken the square root. Either way, it's fine. But that's the gist of that one. Okay? I want to spend time on this one though. That's why, because we've only got 5 or 6 minutes left. Now it says here 0.01 is on this graph, and it says find the equation to fit the parabola. What people struggle with though is the general form of the quadratic. It is this, x minus h all squared plus k. And what a lot of people forget about is this a here. It does not have to be 1. It can be 1. Maybe it is 1 here, I don't know. But you cannot assume that. So, in order to solve for 3 unknowns, we need 3 pieces of information. But thankfully, the coordinate of the turning point gives us 2 of those. We've got a turning point at 2, negative 5, which means that h is equal to what? No, it's actually 2. Yeah, it's negative h. So h is 2 and k is equal to negative 5. Now let's go ahead and plug that in. What we've got is we've got this. Y is equal to a. We don't know that. X minus 2 all squared minus 5. That's what we've got. That's what we know so far, and we just don't know what a is. So how do we find out what a is? Starts with S. Substitute. When x equals 0, y equals 1. We've been told that that point's on the curve. So now what we do is we're substituting. Wherever y is, we replace with a 1. And whatever x is, we replace with a 0. So I'm just substituting that point in. Now, as it turns out, minus 2 squared is positive 4. So what we've got is 1 is equal to positive 4a, which is 4a minus 5. Now, I would expect that from there you can add 5 to both sides, which gives 4a is equal to 6. And then a is equal to 6 on 4, which is the same as 3 on 2. Now I've found that. Therefore, I've found the equation. My equation now, I've found a, is this. Y is equal to a outside of, oh no, not a, 3x minus 2 all squared, that's a 3 over 2, minus 5. And that is the equation that we're after. Now, let me finish this one because I've only a few minutes left. It says here, consider this equation. Find an expression for the discriminant. What did we say the discriminant was? B squared minus 4ac? Yep. Now, b is the coefficient of x. So that's p. So let's write out what a, b and c is. A is equal to 1. B is equal to p. And c is equal to what? Is it 2? It's 2p. Now, b squared, so therefore the discriminant is equal to b squared, which is p squared in this case, minus 4 times a times c, which is 1 times 2p. Now, therefore we've got now minus 4 times 2p, so it's p squared minus 8p. Now that's our discriminant in terms of p. Find the values of p for which there's one solution. What does the discriminant equal for one solution? 0. So therefore we're saying that p squared minus 8p is equal to 0. That's for one solution because that's our rule. We learnt that last time. And now we've got to solve for that. Now I would just do it this way, taking p out as a common factor. p minus 8 is equal to 0. It says find the values of p for which there's no solutions. Now, by the way, what does it say up here? P does not equal 0. So therefore, there's only one solution, and that is for p is equal to 8, because we've been told p is not 0. Yeah? All right, now look, I know that's a lot of theory. Now, just quickly, this stuff next week is circles. We haven't looked at that yet. But what I will say is we're going to look at that fairly soon in our transformations task, which we're going to give you next class. It's a self-directed task, and it's only going to... Yeah, it's another one. So, I'm going to stop this video there. Thanks for your attention. That was great.